So we're going to start our local field trip explaining where we are in the world. So we're in Prince Rupert, BC. So we're on the north coast, one of the largest ports in Canada now, in a relatively remote community. We have a population of about 12,300, depending on the time of the year and the major economic drivers in the area. So as I was discussing, we have a large port, coal export facility, grain export facility, propane export facility, and more interest across the nation of building more export facilities. Third deepest natural harbor in the world. Our population is about 40% indigenous with strong reliance on traditional food systems. And we operate a combined storm sewage system that discharges waste directly into the local harbor with no treatment. And this is where our field trip really starts and begins. What you're looking at here is a visible problem. The city discharges untreated sewage into Prince Rupert Harbor from 12 separate outfall areas under permit first granted in 1980. As you can see, that concrete encased pipe there is a sewage pipe. Raw sewage is discharged into the harbor. It's supposed to go deep underwater, and then the solution to pollution was dilution back then. We dyed our sewage here as we had a leak, and you can see it's leaking right up against the foreshore there, against the ferry, boats, populated areas, and it's a big challenge. This slide indicates all the discharge points. So there's 12 sewage outfalls throughout the community in the harbor. The collection system dates to the early 1900s, which much of that pipe laid before 1960. And now it runs in what the city itself calls a semi-failure state with breaks almost every week. In the most recent stretch, we had 40,000 liters of raw sewage discharged into 2 fish-bearing creeks, and the province issued us environmental penalties. So this is not an isolated system. The outfall was once looked at as an endpoint. And it's not an endpoint, it's an input to a living system. The harbor holds crab, shrimp, urchin, and times its species at risk, including whales, seals, and is in the traditional harvesting areas of various First Nations. Untreated effluent carries pathogens, oxygen demands matter into that web, and it concentrates as it moves up the food chain. Earth systems pull the other way too. Prince Rupert receives around 3,000 millimeters of rain. The water overwhelms the combined sewer, so a wetter climate directly increases how often raw sewage overflows. So sometimes it doesn't even make it to the outfalls. It surcharges into the creeks, land, wetlands as well. Step back, and the real driver is an idea, not a pipe. Coastal towns everywhere treated the ocean as free infrastructure on the assumption that dilution solves pollution. That old adage that we discussed earlier, that the solution to pollution is dilution. Critical system thinking asks where we draw the boundary. Draw it at the shoreline, and the harbor absorbs the cost. Draw it at a wider area, and the cost lands on fisheries, migratory species, cross borders, and on future residents. There also is a scale mismatch. A single national standard meets a small, high rainfall town with a limited tax base, and the two dots do not clearly fit. Climate adds reinforcing feedback, and the highest leverage response is a change in the paradigm, not a bigger pipe. And here's why it's not just a local problem, a local pipe discharging into a harbor on a remote coast. Marine pollution does not respect a municipal boundary. The harbor opens to the Pacific and to the species that migrate across national and international waters. Prince Rupert is also a major trade gateway, so its coastline is tied to global supply chains. The regulatory response is global too. Canada's wastewater rules deliver on a national strategy that is explicitly linked to United Nations Sustainable Development Goals. The same shift is ending raw discharge right along this coast. Victoria stopped relatively recently in 2020, and Prince Rupert is the next hit list. And then I really wanted to move forward in this tour, so we started the tour kind of where Prince Rupert is, our marine outfall, one of 12 that you could get a visual representation, and now we're going to kind of end on a positive part of the tour. How we move forward from this. The correction comes from the Federal Wastewater Systems Effluent Regulations, or the WESR. It's made under the Fisheries Act. They set a national baseline that requires secondary treatment with deadlines staged by risk. Prince Rupert is directed to treat its sewage by 2030. Rather than spend an estimated $200 to $300 million on conventional mechanical plants, the city is building a passive subsurface wetland system that treats sewage using ecological processes. A first investment of over $5 million is funded across 3 levels of government, and the design is meant to be a model that other coastal communities can copy. So we're going to dive into our project that's under construction here to finish off the tour on that positive note.
Behind me is our unique wetland treatment system. So as we showed previously, we have our outfalls. So one of our main outfalls is coming right here. We're going to siphon off approximately 10% of the sewage there to treat through the wetland. As you can see, we're about 60% through construction. We've had 2 major grants from the feds and province related to this project. So right now we're building up, they're basically giant planters. Then we're going to fill with local vegetation soil, and that's going to treat the sewage. There's going to be a pump house station down there that it comes through where we have to do sampling, and then we'll report it back to the province and our provincial permit to see if this system works. We're hoping this system will relieve the pressure to build conventional mechanical systems. Unlike a conventional mechanical treatment system that has a lot of mechanical inputs, so a lot of pumps, aeration, mechanical agitation as well, this is all a passive system. So the sewage comes in. Unfortunately, due to the grades, we have to do a little pumping, but generally it would just come in under gravity. It runs through the vegetation, which treats it, and then it flows out. So there's no chemical addition, very little electrical demand on our grid here, and it's all passive from operation standpoints as well. Very limited cleaning, very limited maintenance, and it should just run like a natural system.
So there we have it. Wanted to do our tour or field trip a little different, where we started at one part of the city, explained the city and the problem. So you can see our outfall there encased by concrete, and then ended the tour on a positive nature. I didn't want it to be all a negative environmental tour here. So this is where the trip ends and where it begins, at a pipe. But the pipe is a node. It connects a wartime sewer network, a rain-soaked coast, a shared ocean commons, and an international policy framework. The local issue and the global issue are the same issue seen at different scales. Treating the sewage here is a small act of repair in a very large system, and a test of whether a regulation written for the whole country can fit one demanding place on the map. Thank you for your time, and thanks for coming for beautiful Prince Rupert, and hopefully everyone can come visit sometime.